The overall goal of this procedure is to fabricate and characterize a disordered optical fiber for transverse Anderson localization of light. This is accomplished by first mixing strands of polymethyl methacrylate and polystyrene and making a preform for the draw process. The second step is to image the refractive index profile of the drawn fiber once the PMMA fibers have been dissolved using scanning electron microscopy. Next, the samples of drawn fiber are cleaved and polished for the optical characterization of Anderson localization. The final step is to test the samples in the optical setup by illuminating the disordered fiber with helium-neon laser light. Ultimately, the output intensity profile of the localized beam is imaged on a CCD camera beam profiler to show the transverse Anderson localization of light. Begin by spreading about 200 PMMA strands on a table, and then spreading the same number of polystyrene strands on top of the PMMA. Mix the strands together and then place them to one side. Repeat this procedure until 40,000 strands of PMMA are randomly mixed with 40,000 strands of polystyrene. Then, assemble the randomly mixed strands into a square preform with sides of about 2.5 inches. Next, have the preform drawn into an optical fiber with a diameter of 250 microns by a company that specializes in this type.